Section 6.4 is on now special types of factoring. There are two specific patterns that we're going to be going over tonight in this lesson, in this video. It is the difference of squares as well as the sum and difference of two cubes. So first, let's look at the difference of two squares. And we have a bunch of examples here, but I'm going to take a minute and write down the formula or the pattern on the bottom here. So it's called the difference of squares. When we're working with the difference of squares, we're starting off with an expression that has two terms. Hey, look, you see two. That has two terms. There are both of which are squared. So it has to be something squared and something squared, or you have to be able to write them as something squared. So when it's that case, now the other thing about this is it has to be a difference, which means you have to be subtracting in there. Otherwise, you cannot use the difference of squares, and therefore it's probably not factorable, other than maybe a GCF. So when you have something that happens like this, you can go ahead and factor it into the quantity A plus B times the quantity A minus B. And let's see how we can actually use this. So up top, in example 1 part A, we have x squared minus 36. Again, we are still asked to factor the polynomial, so we still need to ask ourselves, is there a GCF? Is there a greatest common factor? Which, for part A, there is not a greatest common factor. So then we want to work with, okay, well, can we write each of these terms as something squared and something squared? Can we do that? And the answer is yes. In this case, we can. We can write it as x squared and 6 squared. And the x and the 6 are actually our a and our b values from here. So now we're just going to follow this pattern, the a plus b and then a minus b. So that means this factors into x plus 6 and x minus 6. And that's it. That's all. Nice enough. Now again, we could go ahead and check to make sure that this works by using our FOIL or distributive method to multiply this out and make sure we get right back up where we started. But this pattern is always going to work as long as we have it in this form. So let's go ahead and apply this a few more times so that we can make sure we have a good understanding. In example 1 part B, we have 5r squared plus 8t squared. Now, in this case, again, we're asking ourselves, okay, can we write this as something squared minus something squared? And the answer is immediately no. The reason the answer is immediately no is because in the original expression, we have a plus here. So we automatically know that this is not going to work. It's not factorable. And if it is not factorable, do you remember the terminology for it? That means that it is prime. Part C, we have something a little more involved. We have 25x squared minus 16y squared. So again, can we write this as something squared minus something squared? Well, first off, it is a minus, so that's in our favor. And then, can we write 25x squared as something squared? In that case, we can. That would be 5x, because 5 squared is 25, and x squared is x squared. Here, what can we write in here and square it to give us 16y squared? That would be 4y. So again, this is in our A position and this is in our B position. If we look back down here at our pattern, right, at our pattern A plus B times a minus b. So that's going to be 5x plus 4y times 5x minus 4y. You could also write it in reverse. You could write 5x minus 4y times 5x plus 4y. However, there will be some occasions where it's actually going to kind of make it easier if we write it like this with the plus first and then the minus. But technically these are equivalent expressions. So that's our first special type of factoring. The second special type of factoring is our sum and difference of two cubes. So we actually have two patterns for this. We have one with a sum and one with a difference. So the sum of cubes, if we have, just like the difference of squares, we're still dealing with two terms, an a term and a b term. Now, instead of dealing with squares, we're dealing with cubes. So this has to be a cubed and b cubed. And we're dealing with the sum of it, so that has to be a plus inside. If that's the case, this is going to factor into, are you ready for it? It's going to factor into a plus b times the quantity a squared minus ab plus b squared. Yep, all of that. Now likewise, if we have our difference of cubes, let's go over here. Can you see all that? All right, you can. Okay, if we have the difference of it, so it's going to look very similar to the original, but instead it's going to be a cubed minus b cubed. Our factored form is going to, again, be very similar to our sum of cubes, just some of the signs will change. So this can be factored into a minus b times a squared plus ab plus b squared. And so now all that's left is to check, okay, well, can we use any of these patterns for any of the problems in this example? So example 2 part A, we have n cubed plus 27. So just like before, we're asking ourselves, okay, can we write this as something cubed and something cubed? Yes, we can. We can write it as n cubed, and we can write it as, what would that be? 3 cubed. And then we can look at the original sign to determine which formula we're going to use, the sum of cubes or the difference of cubes. Here we have a plus, so we're going to use the sum of cubes. Now, it might help if you rewrite the pattern just right above it so that you can just directly fill it in. So that's what I'm going to do. A plus b times a squared minus ab plus b squared. So everywhere we see an a, we're going to put in n, and everywhere we see a b, we're going to put in 3. So that's going to be n plus 3 times n squared minus n times 3 plus 3 squared. Now we don't want to leave it this way. Of course, we want to simplify anything that we can simplify, which means we want to simplify this and that. So our final factored form for this sum of cubes would be n plus 3 times the quantity n squared minus 3n plus 9. And that would be our factored form. Part B is something really, really similar. We still have n squared and 27, but now we have a minus. I'm sorry, n cubed and 27. So our A and B positions will stay the same. It'll still be n and 3. But now the pattern that we're going to use is going to be a difference of cubes instead. So that difference of cubes is a minus b times a squared plus ab plus b squared. And let's fill that in. So anywhere we see an a, we're putting n. Anywhere we see a b, we're putting 3. So that's going to be n minus 3 times n squared plus n times 3 plus 3 squared. And just like the previous problem, we need to go ahead and simplify that. N minus 3 times n squared plus 3n plus 9. The difference between these is really minuscule. It's just the first and the second sign. Everything else is exactly the same. Sorry, you can't see that. The first and the second sign, right? That's a positive, that's a negative. The second sign, that's a negative, that's a positive. Okay, let's go ahead and squeeze in that last example there. So in that last example, I'm going to write it on a separate sheet of paper just to make it easier. Oh, we have 8x cubed minus 125y cubed. So just like before, we want to see, can we write it as something cubed and something cubed? And in the middle, we're going to have a minus here because with the cubes, we have an option. So let's see. I can definitely put an x in here, but what about the 8? Can we write 8 as something cubed? Yes, we can, a 2. And then we have 125y cubed. So I know I can definitely put a y in there. But for the 125, what cubed equals 125? That'd be 5. Okay, and you could just check on your calculator. 2 times 2 times 2 equals, oh, 8, that works. 3 times 3 times 3 equals, oh, that doesn't work. 4 times 4 times 4 equals, oh, that doesn't work, and so on and so forth. Now we're going to follow our pattern. Again, this is a minus, so it's a difference pattern. That's going to be a minus b times the quantity a squared plus ab plus b squared. Wherever we see the a, we're going to put in 2x. Wherever we see the b, we're going to put in 5y. And we have to be really careful with this when we get the a squared and the b squared because we're often tempted just to write 2x squared and it looks like only the x is squared instead of the whole thing. So we got to be, again, really careful. So here we have 2x minus 5y. That's easy enough. And then for the second part, we have a squared. So that's going to be 2x quantity squared plus 2x times 5y plus 5y quantity squared. So it's a lot to simplify in that second part. Our 2x minus 5y is going to stay the same. 2x quantity squared means we square both of these terms, so we're going to square 2 and square x. So this becomes 4x squared. We multiply in the middle, so that'll be 10 and alphabetically xy. And then finally at the end we have to square 5y, so that would be 25y squared. And that is Section 6.4, Example 2, Part C. I just didn't have any room on my paper for it. So we have one more example, and that's this here. It doesn't tell us what to specifically use. It does give us a hint, and it does say factor the GCF first, which actually we should always do. In fact, I didn't do that for any of the previous problems. Shame on me. So first, is there a GCF? Is there a GCF? Let's see, we have 8 and 32. We could divide both of those by 8. Can we divide it by 8? Let's see. Oops. Okay. 32 divided by 8. Hey, all right. So that's part of our GCF, 8. And then we have s cubed and then st squared. So we can divide both of them by s. So 8s is going to be our GCF. And just like the previous sections, we'll go ahead and make a factor line down here, and we'll put our GCF down at the bottom, 8s. We're left with just s squared minus 4t squared. So what pattern would we be using here? Would we be using the difference of squares or the sum and difference of cubes? We would be using the difference of squares because we have squares, right? S squared, t squared. And in order to be a squared, it has to be a minus, which we fit into that category because it's a minus. So this is going to be an s in here, a 2t in there. Our pattern for our difference of squares is a plus b times a minus b. Wherever we see a, we're going to put in s. Wherever we see b, we're going to put in 2t. And then finally, we'll take that and drop that down to the bottom. S plus 2t and s minus 2t. So our final answer is 8s times the quantity s plus 2t times the quantity s minus 2t. So that finishes up our section 6.4, and that finally finishes up all of our notes for our first section. So go ahead and review this as much as you need to. Do some of the try it problems if you'd like. Use those PowerPoints and the Khan Academy videos to help you, as well as this as an aid. Remember to at least attempt the homework for section 6.1 to 6.4. Normally that homework would be due before the next class. However, because this is a video, I do want to give you a little bit of extra time just to ask questions. So the homework for this will be due at a later date, which is listed in your Blackboard as well as my math lab. Remember, before the next class on Tuesday, July 11th, not only should you at least start the homework for section 6.1 and 6.4, you need to do the pre-class assignment for 6.5 to 6.7. That pre-class assignment is not accepted late under any circumstances, so please make sure you do it to the best of your knowledge. That'll help you learn any vocabulary and just go over some things to help us expedite our next class. Great job, everyone. Take care.